Good morning. So it's time for some coffee. But then before that, so today what we're going to do is actually to uncover the science behind coffee art from a molecular gastronomy perspective. Well, but then when it comes to the term molecular gastronomy, what is the first thing that comes to your mind? Would you be thinking about food, which can trick our taste bud like this fake egg that I made? Well, in fact, well, for the egg yolk, it is prepared by using mango juice, whereas for the egg white, it is prepared by using milk. Well, milk, well, just like the egg white, it is also a good source of protein. Well, whereas for the mango, well, there's no cholesterol there. Well, or would you be thinking about food in various shapes and forms, like foam, caviar, or spaghetti? Or would you be simply thinking about eating liquid nitrogen ice cream? In fact, many of the people have mistakenly assumed that molecular gastronomy it is a cooking style, when in fact it is actually a branch of science. It is a branch of science which studies the transformation of ingredients during the cooking process, as well as the sensory phenomena associated with its consumption. And for the establishment of molecular gastronomy, it has something to do with the preparation of souffle. And here is the father of molecular gastronomy, Hervé, who is also a French physical chemist. He established molecular gastronomy around the time of 1980s. Well, and the story goes like this. On one Sunday evening in 1980, well, Hervé decided to prepare some souffle for his friends by making reference to a recipe from the Elle magazine. And it was stated that, well, the egg yolks should be added in 2 by 2. Well, but then, well, Hervé decided to simply ignore this suggestion and simply throw all the egg yolks in. And the result was, well, the souffle was not as good as expected. Well, and so on the following Sunday evening, again, he invited his friends and decided to try out the recipe again. Well, and this time, he has a hypothesis in mind. Well, by reasoning that if the 2 by 2 method is better than the all-in method, perhaps adding in the egg yolk 1 by 1 would be even better than the 2 by 2 method. Well, and he did the trick. This time, well, it was much better when compared with his first attempt. And it is at this time that he decided to collect all the old wives' tales and to test them 1 by 1, leading to the establishment of molecular gastronomy. Well, but then you may wonder, how does molecular gastronomy relate to coffee art? So by now, we know that molecular gastronomy, it is not a cooking style, but a branch of science about the transformation of ingredients. Well, and during the process of coffee art making, it definitely involves some transformation of ingredients, like well, from liquid milk to foam. In turn, well, the foam will be shaped into these lovely little creatures. And to share with you more about the science behind this foaming process. So how can liquid milk, well, stand up, well, and well, being transformed into those lovely little creatures like the cats, the dogs, the cute bears, etc. It has something to do with the protein present in the milk. And no matter whether it is the whole milk, the skimmed milk, or the low-fat milk, we can surely find some protein there. And protein, it plays a key role in the foaming process. Well, and during the foaming process, we have to add in some air bubbles to increase the volume of the milk. Well, and to share with you a bit more about the protein structure. Proteins, well, they are some very big molecules composed of many amino acids linking up 1 by 1 as the basic repeating units. And there are different types of amino acids of different properties. Some of them are hydrophilic, that is, water-loving, loves to associate with water, loves to stay together with water. Whereas for some of the others, they are hydrophobic, that is, they are water-hating. They tend to keep themselves away from water. So now, during the foaming process, when air bubbles are introduced into the milk, what we are doing to the protein molecules is that, well, we are exposing the protein molecules along an interface between air and liquid. And liquid here, that is the milk. So now for the hydrophilic amino acids, that is the water-loving amino acids, they tend to stay together with the milk. Whereas for the hydrophobic ones, they tend to run away from the milk and running towards the air side instead. And just imagine, with different amino acids from the same protein molecules running in opposing directions like this, what will happen? Now, the protein will become unfolded. Well, and with so many protein molecules being unfolded in this way, well, and the air bubbles will be trapped among these protein molecules, leading to the formation of foam. So that is how foam is formed. And with science and technology, we now have 3D TV, 3D printing. Well, and now even coffee is changing into 3D. Well, and today it is our honor to have Mr. Leo Chow, the chief barista from Allegretto, to come here and to demonstrate for us the making of the very famous and amazing coffee art in town. Leo, please. Leo, well, thank you very much for coming today. So what are you going to demonstrate for us today? 你今日會同我哋咧示範乜嘢嘅作品啊？
咁我今日會做一隻 3D 嘅貓。
So Leo is going to make a 3D kitten for us. So shall we get started? And what is the first step? 我哋首先第一個步驟係要做啲咩嘅咧？
首先我
So, well, by using cold milk, this can help to extend the time while being exposed to the heat. Because heating, it is important in the foaming process. Well, it can also help to unfold the protein. Well, and so, but then we don't want too much heating, because if there's too much heat, well, the protein will be overcooked. Very much similar to the case when we heat up the milk. Well, if there's too much heat, well, we can find a layer of milk skin there, and it is also a result of the unfolding of protein. So, Leo, let's get started. All right, so first of all, we have to fill the jug with milk. And it is very important for us to have just the right amount of milk being filled in a jug. On the one hand, we have to make sure that there is enough protein for the foaming process. Well, and on the other hand, well, we have to make sure that it will not overflow. Because as more and more air bubbles are added into the milk, the volume will increase tremendously. Well, and this may make the milk overflow. So now that the steam vent has been inserted near the surface of the milk, and we can hear a hissing sound. I'm not sure if you can hear the hissing sound. And that is an indicator that the air bubbles are now being introduced to the milk. So now we have to give the milk a little knock, which can help to break down the large bubbles. Well, when we drink the coffee, we don't want the large bubbles. We enjoy the micro foam with tiny little bubbles being incorporated in the foam, so as to impart the foam with a very smooth texture.
May I ask a question, Dr. Leung?
Yes, please.
You say you need to heat up the milk to make the foaming process. Is there any temperature requirement? Is that minimum temperature or maximum temperature?
Oh, thank you very much for your question, Dr. Leung. Well, and in fact, there is a maximum temperature limit. Like, we have to keep the milk to below the temperature of 68 degrees Celsius, that would be the best. Or the reason is that if, well, it goes beyond the temperature of 68 degrees Celsius, there would be too much unfolding. Well, and to share with you one word, well, which is for describing the unfolding process of protein. In fact, we call that as denaturation. Denaturation, referring to the unfolding process of protein. So now, well, Leo is making the cat for us. Well, and that must be the tail or the ear. I can't tell at this moment yet. Oh no, that's not the ears. Those are the arms with the head, and those are the two ears. And Leo is now using a chocolate sauce to write down some words for us. Wow, very nice. Let's give Leo a big hand. Very good. Well, and Leo, I have a few more questions to ask you. Well, and so, okay. Well, so can you share with us what is the secret of making this cute little 3D kitten? 你其實有啲咩秘訣咧？點樣可以做到呢隻貓仔個形態啊？係啦，咁靚咁生動嘅咧？
其實都係靠佢嘅匙羹，咁就互相咁樣咧協助咁樣筆啲圖一根一根嘅砌積木咁樣樣去做佢唔同嘅部位咁樣樣嘅。
I see. So well, by using two spoons, well, as we saw just now, by using two spoons to juggle the same foam around to shape different body parts. And it is important, well, to build a strong foundation. Well, like playing with Lego. We have to build a strong foundation before we can, well, further build, well, a taller castle or building, etc. Well, and I have another question, well, which is, what keeps the cat floating on the surface of the coffee？ 點解隻貓唔會沉，係可以浮到喺面咁耐嘅咧？可以保持得到？
其實我哋通常會選擇用 cappuccino 泡沫咖啡去做 base 嘅，因為 cappuccino 佢嘅泡沫比較多啲，咁佢個成台就會比較高少少，咁就可以托住佢泡。
I see, I see. Thank you very much. Well, and so, well, it is by using cappuccino with a thicker layer of foam, well, which can help to act as a support, well, so as to keep the kitten floating. Well, and thank you very much for coming again, Leo. Well, and thank you very much for your demonstration. Well, 3D coffee art, well, it is a very good example demonstrating the chemistry between science and art crossover.